Hi, let's continue towards the last part of this series of videos, part 4. In this video, I will calculate those probabilities from part 2, but now using matrix notation. The three equilibrium states are represented by these matrices shown here. Using the convention, the bases ket themselves are written as ket plus, represented by the matrix 1, 0, and ket minus, represented by the matrix 0, 1. Therefore, the respective bra of these kets are bra plus is represented by this matrix, and bra minus represented by this matrix. Since, let me put it to you this way, bra is the complex conjugate and the transpose of the column vector representing the corresponding ket. Exactly what I did here. Now, the rules of matrix algebra can be applied to calculate the inner products and consequently the probabilities. For the first ket psi 1, the probability of finding spin up, as we have already calculated, is given by this inner product within this module squared, and the probability of finding spin down is given by this expression minus bra psi 1 squared. So all we need to do is to calculate the inner product via matrix notation. For the case of spin up, we have bra plus ket psi 1. If we perform this calculation, we have bra plus is given by this matrix, and ket psi 1 is given by this matrix. If we multiply these two matrices, we have 3 over 5, and then we have here the probability is given by this value squared, 9 over 25, as we got before. Similarly, for spin down, we have to calculate this inner product, but now via matrix notation. Then we have the bra minus is given by 0, 1. Ket psi 1 is represented by this matrix. If we multiply these two matrices, we have 4 over 5, and then, as we found before, the probability of finding spin down is given by this value here squared, 16 over 25. Similarly, for our second quantum state, the probability of finding spin up is given by this expression. The probability of finding spin down is given by this expression. Basically, I will calculate the inner products via matrix notation. Bra plus 1, 0, that multiplies 1 over square root of 5, 1 to I. If we multiply that, we end up with 1 over square root of 5, which means that the probability of finding spin up is this value squared, 1 over 5. Similarly, for the spin down, then here our bra minus is 0, 1, and our quantum state is given by this matrix. If we multiply that, we end up with 2i over square root of 5. If we take the more modulo squared of this value, we get 4 over 5. We can keep doing that. Now for the last quantum state, ket psi 3. So you already know the expression for the probability of finding spin up. I'm going to skip this step, and the probability of finding spin down. All we need to do is to calculate the inner products and square it. We have now 1, 0. The matrix is 1 over square root of 10. The first entry 3, the second exponential I pi over 3. This result here gives us 3 over square root of 10. And if we square this value, we have 9 over 10. That's this probability. If we do the same for the probability of finding spin down, we need to calculate this inner product. Now we have 0, 1, 1 square root of 10, 3 exponential I pi over 3. This result here gives us exponential I pi over 3 over square root of 10. If we take the modulo squared of this value, we get 1 over 10. As you can see, all these results are consistent with what we found in part 2, as should be. That's what I planned for this video. Thanks for watching. Catch you later.